Hello, good day. My name is Uche Madokchi Daniel, and today I'm presenting MedSecure, a HIPAA-compliant medical document summarization platform that I built to demonstrate my capabilities in full stack development, machine learning engineering, and healthcare data security. This project addresses a real challenge in healthcare. Doctors spend an average of 60 minutes per patient reviewing medical records. MedSecure automates this by intelligently summarizing clinical documents while ensuring complete patient's privacy through automatic PII detection and maxing. So basically, healthcare generates 30% of world data, yet clinicians lose valuable time manually reviewing lengthy medical records. This creates three critical challenges: efficiency, compliance, accuracy. So for the efficiency, physicians spend up to 50% of their time on documentation rather than patient care. For the compliance, HIPAA regulation requires strict protection of protected health information (PHI). Any AI system processing medical data must guarantee privacy. Accuracy. Medical summarization cannot afford hallucinations. Fabricated information could lead to misdiagnosis or incorrect treatment. So MedSecure solves all these three problems. And how does it solve it? It automatically marks 15 plus categories of PII, generates accurate summaries using fine-tuned language models, and verify output against source documents to detect hallucinations. So let's go to the system architecture. So MedSecure follows a modern microservice ready design with a clear separations of concerns built for HIPAA compliance, scalability, and production grade ML operations. So these are the stage processing pipelines. It goes through from the encrypted uploads to the PII maxing to the medical name entity recognition to the large language model summary, then to the verification and the secure storage. So I will be explaining each of these pipeline one after the other. So let me explain it briefly. So the PI maxing engine, what it does is it uses 15 plus request patterns plus name entity regulatory integration to detect social security numbers, medical record numbers, phone numbers, email addresses, and healthcare specific identifier like NPI and DEA numbers. Then for the medical name entity recognition, then I followed an ensemble approach combining spacey rule-based patterns with birth-based biomedical name entity recognition for extracting medical entities, conditions, medications, procedures, anatomy, and vital signs. Then the LLM summarizer or summary is designed for PEFs, let's say PEF/LoRa fine-tuned Llama 3 with 4-bit quantization for memory efficiency and medical specific prompt templates. Then for the verification, so the verification is a verification agent which are implemented to prevent assassination through semantic similarity scoring, entity consistency checking, and claims verification. And then for the secure storage, I implemented MongoDB with field level encryption for HIPAA compliance. So these are my stack. So I use for the backend, I use First API, PyDAC, MongoDB, logo. Then for the front end, Node.js, Theory CSS, Axios, and React Hooks. Then ML stack, Spacey, Hugging Face, Llama, and sentence transformer. Then security stack, Fenet, PBKDF2, LBAC, and Bandit. So let me give a deep dive on how the PII maxing engine works. So I implemented for the PII maxing engine, I implemented a multi-layer detection strategy. So the first layer uses compiled regress patterns for deterministic high confidence matches. So these are the 15 plus PII categories detected. So you have SSN, your phone, email, I'm checking, maxing, or let me say I'm going to hide all this information. So MRN, NPI, ND, credit cards, and all of that. So then for the layer one, so once it compiles the reverse pattern, then for the layer two, it implements the named entity recognition based name detection, and then for the layer three, then there's a finite encryption at rest, which makes use of 100,000 iterations. and mixes of PBKDF2 key derivations for brute force resistance. Every master operation is audit logged with timestamps and user educations for compliance reporting. So now let me give you a deep dive of the ML pipeline. So this ML pipeline demonstrates my understanding of production NLP systems. So for the named entity recognition, I built an ensemble combining species efficient rule-based matching with transformer-based models from Hugging Face. The ensemble matches results over overlapping entities and outputs unified confidence scores. So you can see the information here. So the results are merged, overlapping entities are solved by confidence, and unified scores are computed for downstream processing. So then when I now have LLM summarization, which is llama 3 plus LoRa. So I'm using a 4-bit quantization, which helps in 4 times memory reduction, and then 0.1% parameter strength for LoRa for the LoRa adapter efficiency, and the 8 MB adapter size versus 16 GB full model. So it is fine-tuned on medical data sets with custom prompt templates optimized for clinical storage, graceful fallback to extractive summarization when GPU resources are limited. So this is this. So for this hallucination agent, so how it works is that the verification agent addresses the critical problem of LLM hallucination. What it does is it computes semantic similarities, entity consistencies, and then there is a claim verification system that checks factual alignment. So documents are flagged if verifications falls below configuration thresholds. So this all of that, and this is so let's so these are why I use LoRa over full fine-tuning, why MongoDB over PostgreSQL, FastAPI over Flask, and then why I had to use the verification agent and why I used an ensemble. So let's just try the platform out. So now to use this platform, you can either upload a PDF, doc, or a text file, or you can just paste the medical document text. So for my demonstration, I'll be pasting a text. You can convert this text into a PDF file and upload. It will still work. So I'm pasting a text, and then once I click summarize, so what it is doing is it is maxing the PII, then it's extracting the entities and then generating the summaries. So now you can see it has done the work. So you can see that for the marks zone, for the PI document, you can see that the patient's name is redacted, the date of birth is redacted, the MRI is redacted, the SNN is redacted, and phone. So those are the 15 PII that I showed earlier, I explained earlier that we're going to be maxed. And then it gives, after maxing it, then it showed the listen. So this is the generated summary. So this is the generated summary. So the extracted medical entities, the anatomy, and not the frequency, conditions, and everything. So this is a full demonstration of the project and how the project works. So what this is to say is that MedSecure demonstrates my ability to architect and implement production-grade ML systems that address real-world constraints, not just model accuracy, but privacy, security, and operational concerns. So Yeah, so thank you for your time. And the complete source code is available in my GitHub, and I welcome any questions or contributions. Thank you.